Alright, guys, I'm here again for you to take you on the road for PCA. I'm gonna be teaching you PCA today, which is Principal Component and Analysis, as you can see here. So, yep, I got my data here. You can, take any data, and I got my code here. So let's run this code. So first of all, import some libraries, and just remember the guys are gonna put this code for you down in the description, so you can go to my GitHub and download the full code from there, okay, and read more about PCA if you want to get more information. This is very very useful to reduce your dimensions. Like if you have a huge data set, then you can see uh, which actually variable or heading or column is most important, and you can select those and use those in your analysis, and don't worry about those which are not very impactful. So to do that, you need to do this import libraries. So I got all pandas, numpy, matplotlib, seaborn, sklearn, all these libraries. So we're gonna quickly run these ones for you guys. So we have all, yep, they all in now. And then we're gonna load the data set, this data set here, which you will find in my GitHub as well. So you can download this data set and play with this data, because it's always hard to get data, guys. I'm providing you for free. So make sure you like and subscribe, okay? And we're gonna run this one. So quick, heading print here. So 5 rows, 47 columns, it's just printing right here. But I have more, in actually the data. So then we're gonna check the first column. If it's not date and time, if it's, then it's gonna skip, because we don't want to mess up with the date and time. We just want to focus on the main data set. And now I'm gonna select only numerical column for the PCA. Remember, PCA is principal component analysis, which gonna apply only to the numerical values, not the word values, okay? No, so just we're gonna take the numerical value. It's already run, and now I'm gonna standardize the data. I'm gonna be standardizing it. So I done that, and now I'm gonna perform the PCA with a large number of components to analyze variance. So PCA, I'm gonna perform this. I put here all the code for you guys. You can have a look and learn. So number of components, I'm taking here 18 is example, which covers most of the time, most of the data. As you can see here, my number of components, so as you can see, in my case, I took 18s, to get 88 or 90, so this is, you can actually visually see them. And now I'm gonna do elbow method for the clustering. So the elbow method, whenever it sharply get flattened, then we choose that elbow, which you guys gonna see here. You see, so this is going all right. Now it's sharply kind of flattening. So I would say the 7 will be the best option. So that's why you say I choose here number of clusters 7 for my KMeans. So I'm gonna run this one. After running that, this is my clusters. As you can see, all color, they are together. And I got this little cluster, and the green is not, is maybe outliers, but it gives you an idea. How this is the 3D view. As you can see, I got my all clusters. I got silt house score is 0.3. So this score lies between -1 and 1. So bigger the better. So more silt house score, more good your clustering is. So try to make it increase. You can play with number of clusters, but you saw here, we can only take here, let's say the best will be 7, but you can go 8 and 9 and see how much silt house is score you get from there, this number here. Then we're gonna plot the heat map, just quickly visualize, see how, like for example, PC1 and PV3, they are related 14%. You can pick any of them. For example, PC4 with PV3 33, and look 80 87. So PC4 is somehow very related to PP2. So all these variables, you can see on the heat maps and see how they are related to each other. Now if you want to save this file, you can run this command. I already have here, so I don't have to, but you can print it and see how your results looks like for PC principal components. For example, 1 is here, 2 is here. You can see all your principal components. These are the eigenvalues and eigenvectors. So if you want to read more, let me know in the comment, and I can give you more information on that. So yep, you can run this and save like I showed you. And now script plot and cumulative variance plot. Let's see these ones to visualize data from the different perspectives. As you see, this is the principal components, this is the explained variance ratio. So so as you see, if we are going, the cumulative explained variance is increasing, and individual explained variance is decreasing, as you can see. So it's giving you idea how these two are behaving. And now correlation circle. Correlation circle here gonna give you a good idea, how your variables, where they are. For example, this is between principal component 2 and 1, because these two components have most important, or most of the values which are very influential to your data set. Then you can see where are they most of them. As you can see, they most of them on the right hand side here, and I would say, this part of the circle. So they are, in this part of the circle. So you see all these are very very similar, related. You can see the relationship between each other, so how they are. I hope you guys like the video. Please hit and subscribe, and let me know in the comment if you need anything more details, and I'll see you in the next videos. Bye bye.